All right, the purpose of this video is to review the laws and the rules of zero and negative exponents and helping you simplify these problems. Now, this is the part of the page where you probably want to write these down. Zero exponent rule means any base, any number, any variable taken to the zero power other than zero is equal to 1. So 5 to the 0 equals 1, y to the 0 equals 1, 1/3 to the 0 equals 1. Anything that's not 0 taken to the 0 power is equal to 1. And the instruction kind of went through why that is. So if you need to review the instruction, go back and do that. But we'll go through some examples here today. The second one is the negative exponents rule. If you have a negative exponent, it becomes a to the negative n equals 1 over a to the n. Now, simply what I like to think of it is this is 5 to the negative 2, for example. This negative, I consider that becomes a fraction. That means I'm going to take that negative and I'm going to write 1 over, and that then what's left is 1 over, and then what's left, if that negative becomes that part, then left is 5 squared, and then you can always simplify that to 5 squared is 1 over 25. So that's the negative exponents rule. Now, if you have a fraction taken to a negative exponent, the easiest thing to do is take the reciprocal. So a fraction raised to a negative power is equal to the reciprocal of the fraction raised to the positive power. So if you see we have a over b to the negative n, we just flopped a and b and made the exponent positive. So 3 over 5 to the negative 3 power is the same thing as 5 over 3 to the positive 3 power. And then you can solve it from there. So those are three very important rules to know to solve these things. So the best way to use this video is to try the problems on your own first. As I'm going through them, you can speed up the video. You can fast forward to things that you need to hear more, but make sure you're writing things down and understanding them. So this walks us through how do we get this? How do the powers of 3 or any power, how do we get that the negative is the negative exponent rule and the zero exponent rule? So this kind of walks us through that. So what is the pattern as the exponents decrease? If we go from 3 squared, 3/3, 3 squared, 3 to the first, what's happening? Each time they're being divided by 3. By 3. And so if we're going to take 3 divided by 3, then 3 to the 0 has to be equal to 3 divided by 3, which equals 1. So we're dividing by 3, or we're dividing by the base. So if this were 5, you would notice the value is being divided by 5 each time. It's all about what this base is. Okay, so they're all 3. So that's what we're dividing by. So then then we have 1. If a equals 1, then what's going to happen? Well, the pattern should continue, right? The pattern should then say, well, 1 divided by 3, which equals 1/3. So 3 to the negative 1 is equal to 1/3. And 3 to the negative 2 is 1/3 divided by, let's see, I'm going to write over here, 1/3 divided by 3. And when we have fractions that we multiply by the reciprocal, remember? So the reciprocal of 3 is 1/3. So that's the same thing as 1/3 times 1/3, which is 1/9. That's what we get here. And so 3 to the negative 3 would be 1 over 27. So that's how we come to these rules of negative and zero exponents. So the power 3 to the negative 3 equals 1 over 27. Which expression is equivalent to 3 to the negative 3 power? So in this case, what's the negative exponent rule? We take that negative, we make it a 1 over, and we take 3 to the third. So 1 over 3 to the third is going to be equivalent to 3 to the negative 3. The exponent value should be the same. If it's a 3, it should be a 3, and the base should be the same. The only difference is instead of a negative exponent, you have a 1 over, and then that same thing. All right, try this one on your own. Pause the video, and then come back and see if you got it right. All right, the key to this one is everything's written out. X is going to be a negative 125 because we have a negative times a negative times a negative results in a negative number. So we apply the exponents rule, expand it, and simplify. And so x itself is negative 125. If we were to write the whole answer, it would be 1 over, or negative 1 over 125 like that. But all we wanted right there was the x value. So what about this one? Iris found a value of 1 over 64, which could have been the expression Iris evaluated. So there's more than one way to get 64, right? 64, I can think of one as 8 squared. So I can have 1 over 8 squared, which is 8 to the negative 2. Now that's none of my problem, none of my answer. So I'm like, okay, well, let's try something else. So if we take 2 to the 6th, that's going to be 1 over 2 to the 6th. That's 2 to the 6th. And 2 to the 6th power is 2 times 2 times 2 times 2 times 2 times 2. So that's 4 times 4 times 4. And that's 16 times 4, which equals 64. So that one is a possibility. Another one I can see right here. See how I did this in fours? I have 4 times 4 times 4. That equals 4 to the third, right? So that also equals 64. So 4 to the negative 3 is also 1 over 4 to the third. So that's going to equal 64 as well. And then this is to the fifth, and we know we need to get 2 to the sixth, so that's not going to work. 6 to the fourth is 6 times 6 times 6 times 6. So 6 times 6 is 36. Times 6, you're going to be way above 64. And on this one, if we take 1/4 to the negative third, remember that is the same as 4 over 1 to the positive 3, which is 4 to the third. So that's just going to give us 64, not 1 over 64. So sometimes you just have to go through and check them, remembering the rules and applying them and see what it equals. So here's one, this is in expanded form. So how could we write this in exponential form? So what does it mean? Let's just take a look at the bottom. 1, 2, 3, 4, 5, 6 A's. So that would be 1 over A to the 6th. Well, I don't have any of those options here, right? So how would I write it in exponential form? Well, it's basically saying, can we take that 1 over out? And we can make that A to the negative 6th. So when you take a look at this, it's A to the 6th power. And because it's negative, it's in the denominator. And that's how we get that. So you can go back and forth both ways. The simplest form, obviously, is whatever the answer is. But if you're starting with a problem, A to the negative 6 will simplify down to that. Okay, so which expressions are in their simplest form? Simplest forms means no negative exponents, and everything is simplified as far as they can go. So, like, you can't add or multiply or anything together. So we take a look. 1/3 plus x to the 7th. Now, on that one, we can't add those together because they're not like terms. The exponents are positive, so that is in its simplest form. So check these others. Which others are in their simplest form based on what we've learned about simplest form? Okay, this one has a negative exponent, so it's not in simplest form. Both of these have exponents in the denominator, but they're positive and they're different variables, so we can't combine those with that addition at all, so that's in simplest form. No negative exponents, all different variables, simplest form. This one has negative exponents. So hopefully that gives you an idea of like what is simplest form. So this one says, how do we determine the value of x? So it's kind of like saying they're putting in, you can see here, a exponent, a variable in the exponent, and we're just trying to figure out what that variable is if it's equivalent to this statement right here. So if we take a look at this, notice we've got g to the x, and that's going to become 1 over g to the 6th, and h to the negative 3 equals 1 over h to the 3rd. Well, we know that's the rule. We just followed the rule. H to the negative 3 has to equal 1 over h to the 3rd. So if this is g to the 6th, what does x have to be right there? And that should be a negative 6 because it's in the denominator and the value is 6. So x, if x is a negative 6, then this would be, make that true and correct. Now this case, what is the value of y? So y is now in the numerator, so it's b to the y over c to the 7th. We have b to the 4th over c to the negative 7th. Well, if this is a negative, that went in the bottom. B to the 4th, it should be the same. So y is equal to 4 because it's not in the denominator, b to the 4th, and it's still up there, so that's b to the 4th. So here's one I want you to take a look at. He simplified this expression. What was the error? So if you see, he has r to the negative 8, s to the negative 5 equals 1 over r to the 8th times s to the 5th, and then simplified them together. What's the error? Well, it looks like we did the first part correctly. R to the negative 8 equals 1 over r to the 8th. Okay, that negative. But what happened right here? See that negative? That means we have to put s underneath the denominator as well, 1 over s to the fifth. So this should be 1 over r to the eighth times 1 over s to the fifth. And then when we simplify, we just multiply straight across. That's 1 times 1 is 1. And then we have r to the eighth, s to the fifth. So he took the negative, used the law of negative exponents correctly on the first variable, but not the second one. What is the value of negative 1/2 to the negative 4? Remember, this is where that reciprocal rule is really helpful, because you can get all sorts of confused with negatives and negative exponents and fractions. So the first thing I'm going to do is I'm going to take this, I'm going to change this negative, and I'm going to take the reciprocal of the fraction. So the reciprocal of that fraction is just flip top and bottom. So that's going to be a negative 2 over 1 to the positive 4. And now negative 2 over 1 is just negative 2 to the positive 4. And negative 2 to the fourth power, if you're taking something that's negative 2 times negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is a positive 4. Negative 2 times negative 2 is a positive 4. And 4 times 4 equals a positive 16. So make sure you're keeping track of the negatives. If you have a negative taken to an even power, you're going to have a positive result. If it's a negative, in the parentheses, taken to an odd power, it will be negative. And remember that reciprocal to get it right. All right, finally, this one. Find the value of the expression. We work from the inside out. So let's take this first. 3/5 to the 0 power. Let's do that part first. What is anything, any base raised to the 0 power other than 0? That is equal to 1. So now we have 1 to the negative 2. And how do we write this? Well, we have to change that negative into a fraction. So that's going to be equal 1 over 1 squared. And that's 1 over 1, which equals 1. So 1, anything to the 0 power is 1. And 1 to any power is equal to 1. Because it doesn't matter how many times you multiply 1 by itself, you're going to get 1. If it's a negative 1, then you might get a negative 1 or a positive 1. But that's a complicated problem to get 1. So hopefully that will help you with your problems. Like I said, if you didn't understand any of these, or if you have other specific questions, please let me know.